Derivative application Unit 2, Tangents and Normal. Well, this is part B of the test on Unit 2. In part 1, we have simple and straightforward questions where we are finding derivatives of different kinds of functions using the rules learned in this chapter. The rules are power rule, chain rule, quotient rule, and the product rule. Right? Now here we need to find, question number 7 is, at what point is the line y equals to 3x minus 1 tangent to the curve f of x equals to x times x plus 5? So in these set of questions which we are covering now, we have kind of application of derivatives, right? So in this, we need to find the point at which given line could be tangent to the given function. So basically, from the line, you can find what is the slope of the line. Y equals to 3x minus 1 is your line, right? So if you write this equation, it is already there in slope-intercept form. You know slope is 3. That means derivative of the function should be 3. And then you have to figure out whether the point matches or not. That is how you have to do the question, right? So you're given a line which is y equals to 3x minus 1. It is in slope-intercept form since it is y equals to mx plus b, right? So you know slope of the line m is equals to 3, right? That is what is known to us. Now if this line is tangent to the function, then f dash x should be equals to 3, right? So we want f dash x equals to 3. This is what we want. So let's find out what is f dash x for this function. You can apply the product rule, that is derivative of x plus x plus 5. Derivative of x is 1. So you get 1 times x plus 5 plus x times derivative of x plus 5, which is 1. And from here, you know it is x plus 5 plus x will give you 2x plus 5. So the derivative of this function is 2x plus 5. Now if I am looking for f dash x or the slope to be 3, that means f dash x is 3, right? So 3 equals to 2x plus 5. Let's figure out what is this value of x, which you can do by solving this equation. So let's solve for it. So we'll take away 5 from both sides. So we get minus 5 plus 3 equals to 2x, and that gives minus 2 equals to 2x, or x equals to minus 2 divided by 2, which is minus 1. Now if x is minus 1, what is the value of y? So let's figure that out. So we'll do it in a different thing for both and see if it is same or not. So for the function f of minus 1 is equals to, we'll plug in minus 1 here, minus 1 times minus 1 plus 5. And that gives us minus 1 times minus 1 plus 5 is plus 4, that is minus 4. So that is the value of point, or the coordinates of the point on the function where slope is 3. Now does it match with the given line? This is what we have to check. Let's check that out. So y equals to, at x equals to minus 1, what is the value? 3 times minus 1 minus 1, which is minus 3 minus 1 equals to minus 4. Exactly same. So since we see that the point minus 1 minus 4 is common, right? It is common to line and function, right? And at this point, slope is also 3, correct? So therefore, we can conclude that yes, at minus 1 minus 4, the given line is tangent to the given function. Do you understand? So at minus 1 minus 4, the line is tangent to f of x. Do you see that? So that is how we have to prove it, correct? It is kind of necessary to show that the coordinates of the points are exactly same, and then only we can say, well, now the slope is same and the point is same, and therefore the given line is tangent to the function at minus 1 minus 4. I hope you understand that concept. Thank you and all the best.